Hey guys, so today we're going to talk about nonlinear inequalities. So we can write polynomial inequalities, and they look like this, where you have f of x is greater than 0, less than 0, or less than or equal to 0, and so on. So let's just take one of those and see what that means. If I have f of x is greater than 0, that means the function is greater than 0. And another word for greater than 0 is the function is positive, right? So greater than 0 means it's positive. And what that means is that if it's positive, it's above the x-axis. All right, so let's take a look at the function here. My x-axis, right, is right over here. And you see that there are some times where the graph is above and then sometimes when the graph is below the x-axis. The way we usually denote that is, let's first identify where the graph is positive. So here in that region, the graph is positive. And how do I say, right? How do I denote that green region? That red region over there? Well, we always go with the x's. And that region, right? If this is negative 1, 2, 3, 4, that's all of the x values from negative infinity to negative 4. Okay. Another place where f of x is positive or above the x-axis is in that region. And where is that? Well, that's from negative 2 to 2. So I say another place where f of x is positive is negative 2 to 2. Okay, now let's talk about when f of x is negative. Well, f of x is negative here, right? So I can say f of x is less than 0 from negative 4 to negative 2. And f of x is also negative or less than 0 or below the x-axis from x equals 2 all the way to x equals or x approaches positive infinity. All right. Okay, so when does the graph then change from positive to negative, right? Well, it changes from positive to negative when it crosses the x-axis. And when does that happen? At the x-intercepts, right? So let's see where the x-intercepts are. There is 1, 2, 3, 4 x-intercepts. But as you can see, right, that the function changes from positive to negative at this x-intercept, and this one, and this one. But at the last x-intercept, the function remains negative. That tells us two things, that the function changes from positive to negative only at the x-intercepts, but it doesn't mean that it's going to change at every x-intercept. Okay? Having fun so far? I sure am. Okay, let's do it. So now here's a question for you. What's the difference between these x-intercepts? What's the difference between the 3 zeros in the left and that one last 0 to the right? Well, some of you are saying it's the multiplicities, Miss Malikian. And yes, you're right. When there is odd multiplicity, the graph will change signs at those zeros. Okay, f of x changes sign at the zeros. But when there is even multiplicity, f of x maintains its sign. Okay, so that means all this is dependent on zeros and multiplicities. Oh my God, that's exactly what we just learned. So let's jump right into it. Okay, how do we solve these polynomial inequalities? Solve for f of x. Get the zeros and put them on a number line to create what we call a sign chart. Then we're going to test values from each interval. So let's do this. First thing, I have an inequality, and I'm going to solve this in the beginning as if I had an equal sign and not an inequality. So here's what we're going to do. Subtract 1, so I got x squared minus 8x plus 15 less than or equal to 0. Factor x minus 3, x minus 5 less than or equal to 0. Okay, from here, what are my zeros? X is 3 and x is 5. I put those on a number line because when I have an inequality, I'm not looking for a value of x. I'm looking for a region where this function is less than or equal to 0 or below the x-axis. So I'm looking for a region, right? Okay. Now, when I put my x-intercepts on the number line, I divide the number line into 3 regions, right? So what I'm going to do now is I'm going to pick representative points from each of the regions, and I need to plug them into my inequality. Now, this whole thing is greater than 0, less than 0. It's the x-axis where y is 0. So I can't plug it into here where I'm comparing it to a 1, right? So I can plug it into either one of these. For me, it's always more preferable to plug it into the factored form. Okay? All right. Now, from the leftmost region, I'm going to plug in, I don't know, I'll pick a 0. 0 is my favorite number to plug in. Okay, when I put 0 into the first parenthesis, I get a negative number, right? I get 0 minus 3, that's negative 3. I don't care what the value is, I just care that it's a negative. When I plug 0 into the second parenthesis, 0 minus 5, that's also a negative. Negative times negative equals positive. So I say in that region, f of x is positive. It's plus. From the second region, 3 to 5, well, let's pick 4. I mean, you can pick 4.627, but come on now. Okay, plug it into the first parenthesis. I get a plus. Second one, minus. Plus times minus is minus. Next, from the next region, I'm going to choose 6, right? So let's plug 6 into the first one, positive, second one, positive. That gives me positive. Okay, now, my inequality was asking me to find the regions where f of x is less than or equal to 0, right? Less than or equal to 0, that means negative. So I look at my sign chart. This is the sign chart. Where do I have my negative region? Here. This is telling me that in the region from x equals 3 to x equals 5, f of x is less than or equal to 0. Okay? So my answer is going to be, the region that you want is between 3 and 5. Now, since my original inequality was less than or equal to 0, it's a closed circle, right? I do closed brackets. Otherwise, I would have done parentheses. Okay? All right. Let's do one more, and then we're going to add in multiplicity stuff as well. Okay, so here, let's move everything to the left side first. So 2x cubed minus 6x squared minus x plus 3 greater than 0. Okay, This is a cubic term with 4 terms, so I need to factor by grouping. Split it down the middle. From the left-hand side, I factor out a 2x squared, and I get x minus 3. From the other side, I factor out a minus 1, and I get x minus 3 greater than 0. Okay? The common term here is x minus 3. So I factor that out. And I have 2x squared minus 1 left over greater than 0. Okay. This one here gives me x equals 3 as an intercept. This one, I set it equal to 0. I add 1. 2x squared equals 1. X squared is a half. So x is, right, when you take a square root, plus or minus root 1 over 2, which is really plus or minus. When you take the root from the top, you get 1, and the bottom, you get root 2. So what I'm going to put on my number line is negative 1 over root 2, positive 1 over root 2, and 3. Okay? Now, okay, so 1 over root 2, right? Root 2 is like 1.4, so 1 over that, that's a number less than 0. It's like 0 point something, right? Just for reference here. Okay, look, now I have 4 regions, okay? Here's what we're going to do. We're going to pick a number from the leftmost region, right? From here, I'm going to pick, I don't know, negative 5. And I'm going to plug it into this step right here. Okay, so negative 5, first parenthesis gives me negative. Second parenthesis is positive. So together, that makes negative. Now, after this, okay, you have a choice. You can either keep plugging in numbers, or you can use multiplicities, okay? So what I'm going to do is, first I'm going to plug in the numbers, and then I'm going to show you how to do it using multiplicities. So let's do that quickly. All right, from the second region, I'm going to pick 0. And here I'm going to get negative, and that's positive. Next, I'll pick 1. So I get negative, and then here I'll get 2 minus 1, that's positive. And then the next one I'll pick, I don't know, 5. So I get positive, and that's positive. Okay? Now, how could we have done this using multiplicities? Well, here it is. Remember how for the first one I got negative? Okay. Now this 0 is the negative 1 over root 2. Where did I get that from? I got that from here. And what's the exponent there? 1. Odd multiplicity means at that 0, negative 1 over root 2, you're going to change signs. Okay? Then we go to the 1 over root 2. Where did I get that? Same place with an exponent of 1. That means over there it's going to change signs. Next, now I'm at the border of the 3. Where did the 3 come from? Here. Multiplicity of 1, odd multiplicity, so it's got to change signs, right? That's how I do it. Okay? So for instance, if this was x plus 3 squared, let me do it with another color. If this was x plus 3 squared, okay, if I had a negative here, since the 3 has even multiplicity, it would have stayed negative over there. All right, we're going to do more of these in the lesson. All right, let's move on. Here, these are pretty quick. So, all right. X squared plus 2x plus 3, right? You actually can't factor this, right? And so you kind of sit there and you think for a minute, okay, I can't factor this. And I don't really want to do quadratic formula right now. But you know what? I'm not really looking for anything except for where this thing is negative or positive, right? So let's do a number line, right? So this is because we weren't able to factor, okay? And so I kind of want to think about it in a different way. Let's get a number line and let's put 0 on the number line just for reference. So now I just want to think about the possible values of this. At x equals 0, is this function positive or negative? Positive. Okay. For positive x values, this function is positive. What about for negative x values? If I put negative 10 into the x values here, I'm going to get like 100 minus 20. So it's still going to be positive. Think about that. So no matter what x value you put in there, you're going to get positives for the entire number line. What does that mean? This graph, which is a parabola, is always positive. So it must look like this. So when it asks me where is it less than 0, I say no solution. It's never. Okay? Now, look at the next one. It's asking us the same function, right? But this time greater than or equal to 0. Okay. This function I know is always greater than 0. Does it ever equal 0? No, but it doesn't matter because the condition is where is it greater than 0 or where is it equal to 0? Well, it's always greater than 0, so the answer here is all real numbers. Okay, next one. Look at this one. This one actually can factor. It's x plus 6 squared less than or equal to 0. All right, so I get x equals negative 6. Okay, all right, so if I pick a number from here, right? I don't know, like negative 10, and I plug it into here, I get positive. But now look, let's talk about multiplicities for a minute. In crossing over to the other side of negative 6, right? Where did negative 6 come from? From here with an even multiplicity. Even multiplicity means no sign change. So this one's positive everywhere. Okay, now this question's asking me, where is this function less than or equal to 0? Well, it's never less than 0. But is there a place where this is equal to 0? Yes, at x equals negative 6. So the answer is just x equals negative 6 or negative 6. Okay, no region. All right. Next, let's talk about some rational inequalities. If you have a rational function, it's basically the same exact thing, except one thing changes. Do you remember how before we talked about for polynomial functions, the graph changes sign at the x-intercepts? Well, for rational inequalities, it could also happen at the points of discontinuity. So all that means is on the number line, we also include the zeros of the denominator. That's all that means. Let's just do one, or two rather. Okay, so here, what we need to do is first find the zeros, right? So if we cross multiply the zeros, and we already know to find the zeros, all you have to do is set the numerator equal to 0. So here the 0 is negative 4 over 3. Okay, so far it's nothing different than what we've been doing. So on my number line, I put in negative 4 over 3. Now, because this is a rational function, you also have to get the discontinuities, the infinite discontinuities, okay? In this case, You set x plus 2 equal to 0, x equals -2. Okay? Most common mistake is students will just forget about the -2, and then you don't have the regions set up properly. Okay, so what I want is for this entire thing to be greater than or equal to 0. So when I pick regions, or when I pick points from my regions, I'm going to plug them into here. Okay, my favorite number is 0. Let's plug in 0. In the numerator, I get 3 times 0 plus 4, so I get positive. In the denominator, I get positive. Positive over positive is positive. Now, the rest of this, we're going to do using multiplicities. Okay? All right, crossing over here, right? Where did the -4/3 come from? Here. Odd multiplicity, changes sign, minus. Now, the 2, right? We're going to cross over the 2, the -2. Where did the -2 come from? Here. Odd multiplicity changes signs. It works every time because it's not a shortcut. It's an actual mathematical definition, right? It works every single time. Trust in the math, guys. Okay, we want this to be greater than or equal to 0. So that is the positive regions here and here. And because it's greater than or equal to, we're going to do brackets. So the leftmost region is -∞ to -2. And then the other region is -4/3 to infinity. Okay, last one. Here, this one, we're going to multiply both sides by x minus 2, right? Because that's the LCD. It's like cross multiplying. So I get x squared minus x minus 11 less than or equal to 3x minus 6. Bring everything to the same side. I get x squared minus 4x minus 5 less than or equal to 0. Factor less than or equal to 0. Okay, what have I got? I've got -1, I've got 5, and I also have the discontinuity 2. Okay, don't forget the discontinuity. Okay, now let's pick numbers to plug in. Again, 0 is my favorite. Okay, 0 is right here. We're gonna plug it into this. Now, it has to be compared to 0. So I have to bring the 3 to the other side, -3 less than or equal to 0. You must compare it to 0. Okay, plug 0 in here. In the numerator, I get -11 over -2 minus 3. That's 11 over 2 minus 3. That's a positive number. Okay, so this one is positive, and the rest I'm going to do using multiplicities. Okay, going over to the left side, where did the -1 come from? Here. Odd multiplicity changes sign. Okay, the 2. Where did the 2 come from? Here. Odd multiplicity changes sign. 5. Here. Odd multiplicity changes sign. Okay, I want the regions that are less than or equal to 0. So that's here and here. That's -∞ minus 1. Bracket. Always bracket. Only parenthesis if it's not less than or equal to. If it's just less than or greater than. And then union 2 to 5. And with that, we finish the lesson. Thanks, everybody. Let me know if you have questions. Bye-bye.